All right, well, welcome and thank you for joining us for today's webinar, High Precision UAS Photogrammetry with Quantum-Systems Trinity Pro and Phase 1 P5 camera, brought to you by Commercial UAV News and sponsored by Frontier Precision. Before we get started, I just have a few housekeeping notes to go over. If anyone has any technical issues using the webinar platform, please try refreshing your browser. That tends to fix most issues. But if you continue to have any technical questions or issues, please use the Q&A box and I will respond right away. Note there is no call-in number for today's session. To connect, you just need to have access to either a computer, tablet, or cell phone for audio, and everyone's lines have been muted. So that you don't miss any shared content or an opportunity to share valuable feedback with us, we do recommend you enabling pop-ups within your browser for today's webinar. For your convenience, everything in the webinar console is fully customizable, so you can move things around, resize the windows, and even turn on captions for this event. And at the bottom of your console, you'll find the resources box. This is where you can download the slides from today's webinar. As always, you can ask questions at any time using the Q&A box, and we'll leave time at the end of the webinar to run a Q&A with our speakers. If we're not able to get to all questions, I'll make sure to forward those off to our sponsor for follow-up via email. And finally, this webinar is being recorded, and you'll receive a thank you email with the on-demand materials within 2 business days. This will just be a link to access the webinar console again, to replay the webinar again if you'd like, or download the slides if you'd like. So again, look for that in your inbox within the next 2 business days. And with that out of the way, I'd like to hand it off to our speakers today. We've got Austin Rains. He is from Frontier Precision Unmanned. And then we've got Nick O'Neilio. He is from Quantum-Systems. So at this point, I will hand it off to Austin and Nick.
Thank you, Laura. So just like she just explained, my name is Austin Rains. I'm a part of Frontier Precision, and more specifically, a division of Frontier Precision called Frontier Precision Unmanned. I'm joined here today with one of our partners, Quantum-Systems, and Nick O'Neilio. He is the regional sales manager for the US for Quantum-Systems, and I am a regional sales manager for Frontier Precision in the South. A little bit of background on myself. I have a Bachelor of Science in Geographic Information Science and Technology with a minor in Geology and a specificity in remote sensing. We both have our Part 107 Small Unmanned Aircraft Systems license, and then I do have my Beyond Visual Line of Sight certification. And then just a little bit more about myself. I've been doing aerial LiDAR and photogrammetry for about the past 8 years, and I've been in the surveying industry for 7 years. And so I'll give it off to Nick so he can introduce himself as well.
Yeah, hello, good afternoon, good morning to those of you who have tuned in for us. As you may know, like Austin said, my name is Nick, representing Quantum-Systems. The excitement behind this payload we're speaking about today, I believe I've met Austin a while back when I first came in, when I was in the industry working while at Phase 1. So this is kind of a neat experience to go to market with. Been in the UAS industry for almost 10 years now, working from a drone DSP, so a drone service provider, and then working on the manufacturing side as well. So with that, I'll keep it short and sweet. And yeah, happy to and be on board with Frontier here today. Austin, back to you.
All right. And so today, you guys are joining us, and we're going to talk a lot about the Quantum-Systems Trinity Pro, and more specifically about its most recent integrated payload, the Phase 1 P5. We have been partnered with Quantum-Systems for a very long time, going on around 7 years now, and we've been through all their iterations of their UAS-specific Part 107 VTOL aircraft. And so the Trinity Pro, we're going to start there, just with understanding, I guess, the intricacies of what the aircraft is. It is a vertical takeoff and landing tricopter VTOL. And a really cool thing about our partnership with Quantum-Systems is that they're one of our only UAS manufacturers who they are full proprietary in terms of their aircraft, in terms of their mission planning software side of things. That's something that is pretty unique in the industry. Obviously, when you're referencing companies like DJI and things like that, they have accomplished that. And so Quantum-Systems is our recommended vertical takeoff and landing fixed wing solution. They have a multitude of payloads. This is just some descriptions of pretty much what they have done, but they are, again, a vertical takeoff and landing tricopter VTOL, and then they are full proprietary across hardware and then also software. Just going on here in terms of their proprietary software side of things, they utilize a software called QBase 3D. And so the cool thing about this, it is going to conduct all of your mission planning for any of the aircraft that Quantum-Systems supports. And also not only the flight planning of the aircraft, but the geotagging of the imagery. So all the PPK processing that is conducted is also in-house at Quantum-Systems. So you're not, left with these images collected from a UAS and then going to have to utilize a third-party software to then post-process the kinematics. You can do that all in-house with their software. And another nice add-on I always like to explain to customers is that their software, you're not paying additional. So whenever you buy their solution, the Trinity Pro, you get a package, and that package also includes the software. And that's a perpetual software. Their mentality, and Nick can speak on this as well, but it only operates with their aircraft. So they don't want to have to, bottleneck you again and make you pay for additional software when it can only be utilized with their aircraft. So with the purchase of their aircraft, utilizing their technology, it is also going to come with their mission planning and kinematic software as well. Nick, do you have anything you want to add to that as well?
No, I think you're right, Austin. To those points that you were talking about, I think a key feature of this, and as we go forward in the industry, and new systems come out in our family, what we talk about is what people see on the LinkedIn stuff housed with all of our aircraft. So whether this be soon to be, whether if we have a drone in a box system coming, if we have able to sell the ability to sell vector on the commercial side, these are all going to be housed within QBase. I think you made a good point on that. All the sensors and everything like that is all housed within QBase. These run off Windows-based operating systems, so that's a key thing to note. With some cool stuff in the as far as like tablets and that sort. But today, like Austin said, this QBase flight planning software is running off of Windows laptop.
Yeah, just going on here, really want to just talk about what Quantum-Systems has done. So they created an aircraft, they've had multiple iterations and they've always improved upon that aircraft. When you think about a fixed wing UAS, we started with belly landers, and then, those were very efficient. If you think back to the days of, the UX-11s or the SenseFly EBXs, those aircrafts, they serve their purpose in the industry, but, the longevity of the aircrafts that we deal with now, we want to maintain their builds, and we want them to be able to be used successfully for years on end, and that comes with the VTOL. So Quantum-Systems has had multiple iterations of their design, and something I didn't mention about their design specifically is that it's not just a non-unique VTOL. You find those a lot in the industries with VTOLs, things like that. But with Quantum-Systems, it's a very specific design that you're not going to find that design on a different platform. They build their aircraft and it functions in a way very efficiently that's very unique and proprietary, again, to them. And they partner with companies like us to not only be trained and licensed support staff for them. We're pretty much an extension of Quantum-Systems in the US. And so, when a problem happens, you're not left with having to try to, utilize just only the manufacturer, but the partners. And like Frontier Precision, we would be able to support you. We conduct all our own trainings. We would support you in any issues that you had with your aircraft. But that's something that, Quantum-Systems was able to realize that they needed to partner with valued resellers like ourselves that have the expertise and then have also the industry foothold to be able to apply this stuff. Because obviously they're great at manufacturing an aircraft, but Frontier Precision, we have, we have customers in all different applications. we're obviously a heavy geospatial company, 36-year-old being Trimble dealers. And so a lot of our customer basis comes from the surveying, the engineering disciplines, but we extend into public safety, we extend into high linear asset management, things like that. Vegetation encroachment is big, and so we have the ability to get their product in a lot of different applications and prove it in a lot of different applications. And so that's just a brief overview of Quantum Systems and what they've done with the Trinity Pro with their most recent model.
And Austin, we had a few questions come in. I guess I'll answer the first. We'll kind of flip-flop here. It looks like, does QBase install to a laptop? It does. This is all in our starter kit, basically a QR code that takes you to a link for installs. You'll get file keys, and that is installed on your computer. And then secondly here, it looks like, is the Trinity controlled with a dedicated controller or via the software? So it is done with a controller. So we basically have branded essentially an Xbox controller that you are controlled and have control. You can do that two ways. You can do that via hardwire with USB, or secondly, you can do that Bluetooth. Austin, on that second question, I know you're probably one of the more experienced Trinity Pro users with what you guys do for us. Is there a certain way you prefer that controller to be connected, or Bluetooth?
Yeah, no, I definitely, for all my trainings that I do for Trinity Pro users, and I'll add that we just conducted the Texas DOT, so they have partnered with us and they are utilizing the Trinity Pro for their fixed wing solution, and also 3 of the payloads that Quantum Systems has done. And when we did their training down in Austin, Texas, something that you find with just a traditional laptop is maybe only a couple of USB ports, maybe a couple of USB-C ports. But what the controller that they have has the ability to do is utilize a wireless connection. And so you can have your long-range modem, that is the telemetry, the connection to the aircraft. You can have that plugged into your PC. You can also have their ADS-BN receiver that comes as a package with the Trinity Pro. So you're able to, on QBase 3D, when you're flying, you're able to see all aircraft that are passing by. So you'll see their call signs, and so that is utilized with either a USB or a USB-C. And sometimes, you would be like, well, how are we going to connect the controller? Well, they have thought about that. You can use 2 AA batteries, and you can connect wirelessly via Bluetooth. So utilize those 2 ports, and you can be roving around with your controller. And it is a very valuable asset. But I will tell you that the Trinity Pro, it is a surveying machine. It is as autonomous as you can be. So that controller is really only for the landing procedures. You'll plan everything in QBase 3D from takeoff all the way to landing. If you never wanted to touch the controller, you wouldn't have to. But it really windy conditions, things like that, or something that crosses your path. I mean, you're flying a mission, and then maybe something has now landed on your landing location. You might need to alter that landing position. That is what that controller is used for. But me and Nick were actually up in North Dakota last week, and we flew on a very, very windy day. And even then, he had the controller in his hand, but he pretty much maybe made a couple inputs, maybe, and it landed within the tolerance of its launch location or its landing position. And so, this thing is going to be very autonomous. There's not going to be a huge need for human intervention, but they have thought about that, and they have given you the ability, if you do need to intervene in landing and bring the aircraft up, or move it around in its vertical state. And so just another safety net that Quantum Systems has built into their aircraft. And just going on here, this is what the big portion of this webinar is for, is the Phase 1 P5. And so it's their most recent integrated payload for the Trinity Pro. A very cool partnership with 2 of our partners. So Frontier Precision is partnered with Phase 1, and they're also partnered with Quantum Systems. And when they made the relationship, and they pretty much gave the rights for the P5 to be integrated to the Trinity Pro specifically. I mean, it is a very innovative camera. You're getting 128 megapixels with 2 different lenses that you can utilize. And we'll go into this a little bit, but when you're looking at the GSD and the resolution that can be attained at, the Part 107 maximum altitude limitations without a high altitude waiver, et cetera. I mean, that's when you get into, extremely, extremely high resolution, high survey grade validity with photogrammetry. And Nick's going to share some images that he has collected, that we've collected, so you can really see what you can attain between that, ground level to 400-foot maximum altitude allotted with the Part 107 license.
Very good. Yeah, we'll get into that. Like Austin was hitting on, I think for us, this being the third sensor Quantum-Systems has released in 1 year, I think that's a cool statement to say about the state of our company and what we're building and growing. As far as a manufacturer standpoint, I know, multiple dual use payloads are wanting to be used out there, so that people want to interchange their, we're adapting. The phase 1 was the third of 3 sensors released in a 12-month period. Yes, I know we released this. I believe the first time we released this, like anything in our industry, was back in November of last year. And so to Austin's point, these will start delivering beginning of November. So these are ready for order. Like he said, there's 2 different lens options. We have a 35 millimeter and a 80 millimeter. The images you'll see here in a little bit after Austin gets done and we get into some images is with the 80 millimeter lens option. These are metric calibrated cameras. Of course, what's the advantage there? It's free from that geomatic distortion. Some key selling points that we're, kind of preaching to our end users are the uncompromised absolute accuracy. You're looking at robust data capturing. And then, of course, the purpose-built for readily available UAVs with Trinity Pro. Some of the use cases that we're doing these first mover programs, of course, the survey realms. A big one for us that we found recently is for roof inspections. And the gas and bridge as well. Yeah, Austin, I'll let you go to the next one.
Yeah, and so we're going to go in detail of this here on the next few slides. But when you're looking at just the coverage that you can attain with a camera like this, and just the increase in resolution, these are some metrics that we've been able to derive by utilizing something like a P5 from phase 1. But when you are able to attain the same resolution as a 42 megapixel sensor at a higher altitude, you're able to be so much more efficient because you're able to fly higher essentially. And so up to 66% more efficient, more coverage that you can attain and still achieve the same GSD that you would have to fly it with a lower megapixel camera, like something more traditional, like a Sony RX1, which is going to be 42 megapixel. When you get into like a Sony ILX LR1, which is pretty much industry standard to date, which is also an integrated payload for the Trinity Pro, you're at that 61 megapixel range. But still, whenever you're able to achieve, the 3-digit megapixel resolution, you can fly so much higher and still achieve what you need. So you're just covering so much more ground. And the same concept with this second bullet point here. You're just able to cover so much more ground. So what does that do? That allows you to capture less images. And again, if you're at same altitudes, low resolution camera, the pixel coverage that you have for every single image, so the ground sample distance that you're able to achieve, is so much higher when you have such a higher megapixel camera that, when you're really working with those survey grade requirements, and when you're able to, see a cotter pin on a substation or something like that from an altitude that's UAS, that's not really able to be achieved unless, with a lower megapixel camera, unless you are flying extremely low, which with fixed wing, that's not something that we really suggest. Kind of the floor AGL that I would fly the Trinity Pro at, just because it's a fixed wing aircraft. It's not something that's traditional in terms of multi-rotor. You can hover over things other than in the vertical state. That's around 50 meters or 150 feet. So whenever you're trying to achieve high resolution and really pick out very intricate features on the individual images or on a constructed orthomosaic or a 3D model, you're going to want the high resolution from something like a phase 1 P5. And that's the whole concept of integrating it to the Trinity Pro. And this is just kind of going on a little bit about, their whole workflow, from QBase 3D flight planning and then executing the flight to data preparation. So when they're having, when you're able to take that imagery, import the proprietary file format from phase one, which is IIQ, and then you're able to convert those images into a usable format of a JPEG that you can then process in, traditional photogrammetric softwares like Pix4D, Agisoft, Context Capture, Trimble Business Center with the UAS master, things like that. They have that all built in. So that free software that we talked about with your purchase of hardware, it's not only just going to allow you to fly the thing, it's going to allow you to process the imagery and get you to a point to where the only thing you would else need is to have a photogrammetric software to process that imagery, that high resolution imagery.
I think one of the questions came in where we have Austin. The Trinity Pro is PPK. So the PPK processing, we do not offer or provide RTK. Let's see here. Let's answer a couple more of these. Is it possible to install in a helicopter? That is yet to be seen yet. I know with this sensor, phase one, with the GS120, this is kind of a similar type model and sensor they have with it as far as the camera back, and that has been installed on the helicopter. Is the P5 hooked to the onboard G? So yes, all of that is in the XF data. So at the end of that, you will notice that all of the camera, all the internal parameters are recorded in the XF file. And we do have a calibration certificate as well that we provide to that calibrated camera.
Yes.
What else?
And I will just say one thing. I know that the RTK topic was brought up. Whenever you're talking about RTK in relation to a surveying application, PPK is always 100% going to be more accurate of a procedure in terms of accurately geotagging the imagery. RTK is great, real time, and it has a space, or it has a place in the industry. But what you're able to do when you reference imagery, the geotags of images to a static observation, you're able to go forwards and backwards processing versus real-time kinematics, RTK, it's in real time. So the accuracies that you can attain by utilizing a static observation that you can then, in the surveying environment, you can either key in known coordinates or you can process that static through Opus, the online positioning user service, get an Opus corrected coordinate, apply those coordinates, and then process your imagery. That's how you really get to survey grade accuracies. And so that's why they utilize PPK, because it's a surveying tool. It's not just an aircraft that can do a lot of things. It is, but they want the data that you collect to be able to be used in a surveying application, from the LiDAR that they collect with the aircraft to the imagery to the multispectral, all their different applications with the payloads that they've integrated. I'm trying to track these questions as well. Let's see here. Let's see. We got max control range, has gotten a BB loss waiver for Trinity. Yeah, the max control range, we're looking at kind of around that 2.5 to 3 mile range with the long range modem. So within visual line of sight. It is a visual line of sight aircraft. That's not to say that a BB loss waiver cannot be submitted. I do see that question here. In terms of having something like a detect and avoid system, it does not have one of those installed on the aircraft. So to get a geographically constrained BB loss waiver would be pretty difficult, I would say, with the Trinity Pro. But something high altitude or geographically constrained, that's something that can definitely be submitted to the FAA and would have a much better chance of being approved if you had a geographically constrained area that you wanted to fly BB loss. The cool thing about QBase 3D is they have built-in workflows to be able to do those BB loss missions. It's called data link loss tolerances. And so if you do fly beyond the radio range and you have dropped signal, you can give allotted time for that connection to not be regained and to continue on the mission for the aircraft. Because everything that we do, just like with traditional aircraft, it's going to be uploaded to the aircraft before takeoff. So no matter what, it doesn't need to maintain that connection. Obviously, for the GCS, the ground control station, to receive the telemetry, you need to maintain that radio connection. But the aircraft, it knows what it's going to do regardless of the connection. And so you can set tolerances. If you knew you had a BB loss waiver If you're doing a long linear corridor that maybe you had a high altitude waiver, you could go BVLOS on this geographically constrained area. You can program the aircraft to continue on its mission by certain limitations of a link loss. And so, Quantum Systems builds in these things because they want the aircraft to be able to be utilized in a ton of different ways, not only just the visual line of sight aspect.
And then moving on, Austin, I believe next is the video you were wanting to show.
Oh, yep. So let's go ahead and do that. Let's see here. Perfect. So this is just going to be a process of QBase 3D. It's going to be a very simplistic mission planning process. I just want to show you how easy it is. So the first thing you see here is going to be the selection of your aircraft and then the selection of your payload. So the Trinity Pro here, you can see that link loss tolerance there at 90 seconds. You can change that. And then we're going to select the P5 at 80 millimeter lens. And then what you would do there is I'm going to plan a corridor. The cool functionality is if you had a KML, either a polygon or a polyline, you can easily just import that and it's going to build its corridor or its area mission off of that KML, that point or not point, that polygon or polyline geometry there. And so you can see here, for this corridor mission, you can set a width of the width that you need to attain on the center line. And then you'll be able to, I know I go pretty quick here, but you can also see the GSD that we're able to achieve with that 80 millimeter lens. This is going to be the takeoff and landing. You would just pretty much set the location of the aircraft. If we were connected to the aircraft, you would see an aircraft icon, and then you would transition into the wind, set your flag as your landing position. The Trinity Pro also has a unique functionality that all other vertical takeoff and landing aircraft really don't have the ability to do. Is going to be a circular landing pattern where it will descend down to a programmed altitude and then simultaneously kick on the back prop to vertically transition right over the launch location. Then also, just another safety mechanism that's built into the aircraft. You can have a safe return path. If you knew that regardless of something, an RTL that's keyed in, a return to land, a link loss tolerance that hasn't been regained, and you knew you could not transition back at a certain altitude from a certain location on your area, you can set certain paths that the aircraft will fly back to your home position that you know is safe. And so this is just kind of going through showing the progression. We have our takeoff and landing. We transition to our area. You can see we're achieving around 0.5 centimeter per pixel resolution, which is, that is pretty extreme resolution, and that's achieved from 150-foot altitude. And so, when you're looking at stuff like that, that's really how you get to be able to read barcodes off of things when you're at those altitudes. And then you would just simply go into the monitoring mission page, and then this is how you would induct the mission. I know that was a crash course and very fast, but that is what you would do, and that is the ease of use. And we conduct trainings for people in terms of photogrammetry. We do a 1-day training. If it has LiDAR involved, we'll do a 2-day training typically. And so we have the confidence with our new users that we can train them in a day or 2 days to be able to conduct these missions safely and accurately themselves.
Good stuff. I guess there are a couple questions in here. I'll give you a little break, Austin. I'll run through. Is the camera good for transmission inspections? Good question. I'll show some imagery later, which I think it would be super successful in that environment.
Oh yeah.
Depending now, the one thing about Trinity Pro in the hover mode, that's not available. So this will cruise down a corridor, typical cruising speed of about 18 meters per second. But some of the images I'm seeing, and Austin, correct me if I'm wrong here, but I do believe it could be somewhat successful. Now that's all going to depend upon what the people are looking for on those transmission lines.
Yeah. No, I would completely agree. I think linear asset inspection, transmission, or distribution lines is one of the biggest applications for the P5 in a photogrammetric sense, because, sure, it's not going to be the traditional inspection that you guys are maybe familiar with a multi-rotor and a low megapixel camera, or, thermal, or whatever you're doing your inspections, high zoom capability, where you're hovering around a tower or something like that and taking images. You would be flying over the center line and with adequate overlap on maybe a flight line on the center of the corridor, and maybe on the side, and then the opposite side. With the field of view of the camera, you're able to get that pixel data on the facade coverage of the tower, and then obviously the nadir coverage from the one that's on top of the lines, and the resolution that you would then be able to attain on each image. It wouldn't be utilizing a camera that you can zoom into and then review the image that way. You would or you would zoom in onto the asset and then take the image. It would be a high resolution image that you could then zoom in and still see the resolution on the individual image. And so it's a, think about flying for an hour and 15 minutes, with the Trinity Pro on a transmission line corridor, not going the multi-rotor speeds that, from around 5 to 15 meters per second. You'd be cruising at on average around an 18 meters per second speed. So you're moving faster. The camera shutter is able to keep up, and you're able to take a lot of images that then you would review as an inspection purpose and still be able to read and understand the intricate details. So I think the P5, phase one in general, even on their man side of things, and Nick used to work at phase one. That's right. They are more so such high resolution imagery to utilize inspection based purposes versus, sometimes they're so high resolution that the stitching it's going to take longer, and so that's we would even you can convert the IIQ files down to a lower megapixel just to construct an orthomosaic and a 3D model a little bit better. But phase one, I think their bread and butter is that high resolution at maximum that you can really analyze an image and pull things that you wouldn't be able to see on other lower resolution cameras on their still images.
Good stuff. And then before Austin goes to the next slide, there's a couple here I can answer. Is there a nose FPV? So is there a first person view on Trinity Pro? No. Our operator, Alex, so we do have a couple people that have done that. And I will say you have to have another Windows-based computer, so some type of laptop that has QBase activated within that for a handoff type procedure. So, yeah. Austin, back to you.
Yeah, and this is just going to show some projects that we've actually conducted. So, what is it great for in terms of the Trinity Pro with any of their cameras, specifically the Phase 1 P5, large acreage, long linear corridors, pipeline right-of-ways, as-built, after-built, overhead power is what I'm referencing with OHP, high-altitude waivers that we can talk about. Because, again, think about the coverage you can get if you're not, and the resolution that you're still able to attain if you're not limited to that 400 feet. If you have a geographically constrained area and you do get a high-altitude waiver through the FAA and you're able to fly this maybe 600 feet, 700 feet, AGL, geographically constrained, and Class G airspace, that's covering some ground. So that's what UAS is built for, is to be as efficient as possible. And that's what VTOL fixed wing UAS is built for, to be even more efficient than traditional multi-rotor. But you can see here, this is just a project, and you can see that this is 2,500 acres. We were able to construct or capture over 10,000 images in one day, and then construct those in Pix4D Matic that you see here there on the right. That was flown with the Trinity Pro. So you can see here the flight lines or the trajectory of what we flew, and then how that correlates to a stitched together 2D orthomosaic, and then which is derived from a 3D point cloud. So that is, that's the efficiencies that you can attain. So, think about 8 flights being able to cover 2,500 acres, very high resolution, or how long would that take you to conduct it with a multi-rotor? That's really where these things find a avenue into different industries, is because they're just increasing efficiency, which in turn increases profitability. And I'm going to let Nick go into this. I tried to do my best, but obviously with PowerPoint, this is going to be the nadir image on the left, and this is actually from the flight. If any of you were at commercial UAV and went to the infield demo, we flew the Trinity Pro with the Phase 1 P5, and this is one of those images. So this is a P5 camera image, and then this is zooming in, but obviously this is just a picture of yours. I'm going to let Nick showcase his images, which are going to be a lot easier to understand the resolution increase and how great this camera really is.
Yeah, Austin, can you give me a verbal yes if you can see my screen?
I've got it.
Right on. So what you're looking at here, these are some areas, and with fall happening everywhere, I think for most of you out there today that spend most of the time in the field flying, collecting, we're starting to see some color change as well. But some of the key features here, I mean, as you can tell, talk about crisp, like holding the image, no pixelation on corners, not just the middle, is super pretty sweet to see. And as you can see here, this is at 400 feet. We're able to see a no parking time or no park street sign from up above that I wanted to bring out. I thought another cool point was this photo right here. For those of you interested in Corvettes, as you can see, let this load. We got a beautiful black Corvette from above. And then lastly, for some roof inspections, which actually I'm going to bring up, it is voting season for those of you that don't know, who haven't been seeing the signs and stuff, but I thought this was a pretty cool feature to show. This was at 400 feet. But those are what I have. I do have a couple examples from, let me see here. I'm going to pull up some roof inspections. Let me switch my screen here to the other application. So what we figured out with roof inspections, so this current user here, well, if it loads, stand by. Well, anyways, I thought I was going to be able to share that. Essentially, with roof inspections, what we were able to see, basically they were currently flying another fixed wing platform at 186 feet to achieve a half an inch per pixel GSD requirement on these roofs. And essentially what they're going to do with that they then flow this into their software, and then they can go to these roofing contractors and provide a software for estimates after a storm. So essentially with what they're getting, they're able to fly at 400 feet with this phase 1 P5 80 millimeter and achieve that same half inch per pixel GSD for their requirement. And then essentially, I think Austin hit it on it earlier. I know AI, it's a buzzword. Yes, I understand. But I've, from my days when I was at phase 1, carrying it on to now at Quantum-Systems, with these AI softwares that we're going into as far as processing, that sort of thing, I think it's a good saying to remember: you feed good stuff in, you get good stuff out. So that's a key thing as we build and grow these models.
Yeah, guys, and that's really, what I had for you guys. And I know there's been a lot of questions, and I think we're going to open up to some more questions. But here's my contact information. Nick, if you reach out to me, I'll give you Nick's contact information. But like I said before, we're an extension of Quantum Systems. And so, we are active users. We're utilizing this every single week. Believe it or not, I probably shouldn't say this, but I'm actually conducting a training today. So by giving this webinar, I'm actually conducting a training for the Trinity Pro right now. And so we are active users all the time. Please screenshot this. If you have any questions, please reach out to me. I am the Unmanned Regional Sales Manager of the South. But if you are in a different region, I will extend you to my team who are just as experienced with the aircraft, and have the same amount of knowledge with the aircraft. And so Frontier Precision, our team, we cover the entire United States, including brick and mortars in Alaska and Hawaii. And so if you have any questions, please reach out to myself or any members of my team.
Austin, before I get in, I see a question here I'm going to share. Someone asked, can we see a zoom in on a tree or any other plant? I will be happy to do that real quick. There are a couple trees in here, but as you can see, it's loading at the moment. Trees, let's see, I have other things I could zoom in on for folks. Let's go to this image. We got some trees.
If anyone also, needed some example data sets, example imagery, please reach out and we can give you that example imagery to run analytics on your own end. You really have an image in front of you that you can see. We're doing the best we can on this webinar to show resolution, but having it physically in front of you, you're really able to see the full potential of what this camera is able to do.
Laura, I think we will conclude our side from Austin and myself and pass it back to you.
Great. We have a couple questions that have come in, so we'll get through a few more. A question: can the Trinity be launched by hand to avoid launching in wind?
Austin, you want
to? So, Yeah, so
About our
no.
experience last week.
Right. So no, you would not want to launch it from hand, but they do recommend launching from their case. So you would never really be in a situation that you would want to launch it by hand. It's going to vertically take off and then transition. So, when we were in Austin doing the previous training for the DOT, we did a lot of the flights from a 6-story parking garage. And so the software and the Trinity Pro is able to, even if you launch vertically from a much higher elevated surface, it's able to understand that. It's called ATO altitude, above takeoff altitude. And it's able to come back to that same elevation. So you think if, oh man, like I don't want to launch from a roof and then have the aircraft think that it needs to land on the ground due to the SRTM data, it's going to understand its altitude and land back on the roof. If you know anything about quantum systems, they're headquartered in Germany, and they do a lot of their test flights off of their roof on their headquarters. And so, you would never even be in a situation that you would need to launch it by hand. And they've thought about that. It would be something you enact the mission, it vertically climbs to a programmed altitude, and it transitions out to fixed wing flight mode. And then it will come back and retransition to a programmed altitude and land over its launch location, regardless of what the SRTM data says, because it's all based off that ATO altitude. Then in flight, it bases its terrain following off of that satellite reference terrain model data.
I see one in here. I have an answer, but I'll. How many control points, Austin, for 10,000 images and 2,500 acres? I would guess.
So, yeah, so 8. I would probably put around, for LiDAR photogrammetry, GCPs that you would need. You don't need any of them, but I always say that that's also a buzzword. People who say you don't need any of them because RTK or PPK. In the surveying environment, you do need something to run a residual accuracy assessment against. And so if you don't have any control out there, there's no way of validating the data, regardless of how accurate your images are or how accurate your processing is. But on average, when it gets to projects of that size, we approximately place a GCP target, around 1 every 100 acres. So somewhere around, 25 to 30 GCPs, making sure to cover any vertices in the environment. So you can see here, we don't have to go back, but that project that you showed there, or that we had on our slides here that shows this, those are all GCP targets. And so those are tagged GCPs that we placed, and that's around 2,500 acres. And then, just for the surveying environment, I always love to get any additional natural ground data to just validate my Z, just to give the confidence to a licensed PLS that this data that we're deriving from remote sensing, either photogrammetric or LiDAR or what have you, is accurate enough that they can use it for design. And so that's, that really comes back into how many does he have confidence, how many does he want to place, but it's not something like historically where PPK was just by tagging GCPs on, metric level accuracy images, we're able to geotag the imagery down to a much higher level of accuracy. So the construction should need little to no intervention in terms of dynamic georeferencing or anything like that, which is what you are doing when you're tagging in these photogrammetric softwares.
Can I use an IMLA GPS base station to sync? Yes, you certainly may. You can use R10. I mean, there's a Leica. I mean, you have a base station. You want to use it? Certainly can go into that file.
Yeah, and we didn't touch on this, but as the base package for the Trinity Pro, it comes with what's called an iBase, which is a little peanut receiver. And so if you are, without any resource to get static data or INX data, and you're not close enough to a core station run by NGS, you don't have a GNSS base station locally to you, they provide you with a method of collecting static data. It's called the Quantum-Systems iBase. Now, am I going to say it's as good as a Trimble R12i? No, but it's designed to be able to be set up on a known point and collect 1 second static that you can then reference back your imagery or even your LiDAR by having that static data that's collected at the same interval as your flight.
At 18 meters per second, I'm assuming you're saying cruise speed. Can you add a thermography sensor? We don't have any thermography sensors, so Quantum-Systems does not, but if that's something you want to look into and do yourself internally, customly, happily, I would think that would be okay. Are the payloads plug and play, Austin?
They are, and just a note on that thermal question, there's no thermography specific, but they have integrated the MicaSense or the AgEagle MicaSense Alton PT, which has a thermal band. So you can attain thermal imagery by utilizing the multispectral specific sensor of the Alton PT, and they have also integrated the Red Edge P as well from MicaSense or AgEagle. AgEagle now owns them. But they're known in the industry as MicaSense. So you do have that ability to get thermal with the Alton PT.
Is the P5 camera NDA certified? That is something not to date, but that is something we will certainly get on board since with Quantum Systems being NDA certified. That's something I'm sure we will work alongside with here shortly. Austin, can overlapping photos be viewed in stereo on 3D soft copy photogrammetric workstations such as Date?
They can, yeah. Just whatever your application, the big concept is that you're going to be able to have that imagery ready to go out of QBase 3D, and you can utilize it however you would like.
And then lastly, before we let everyone go, we're about 45 minutes, is Trinity pending blue list? I think, Kenneth, I see you're asking that. So we are working with the AU VSI organization on that. I know that's a big term, but my kind of statement to that, and Austin, you may have something different, I'll let you go, but blue list is not a law. I think it's important being on front lines, which our systems are, but Austin, over to you for a answer from you.
Yeah, no, it's, the blue list has a place, and for certain jobs, you obviously utilized to have a blue listed aircraft. And we have those options in terms of, do I think that the Trinity Pro, it's, a deal breaker that it's not? No. And we've seen that by, again, the DOTs that have backed us and that have backed Quantum Systems to utilize their aircraft. If the DOT is doing it, that's about as compliant that you're going to need to get. And so, we have DOTs utilizing this technology, specifically the Trinity Pro, with 3 of their different payloads. And so, they have been able to see the compliancy that it is able to attain. And, the blue list, I'm sure you guys have all seen the iterations of the blue list and how it started and how limiting it was. And then the iterations we add, and now they've had enough time to where certain aircraft have been approved. But, it's something that we are typically not turned away to use the Trinity Pro on certain projects. And so I wouldn't make that a deal breaker because, the blue list is still very limited. And unfortunate as that is, that's why we have other things coming out, other lists that are being accepted, the green list, things like that from AVSI, because they want to utilize the most technologically advanced solutions out there. And sometimes that is not what has been, it's just very difficult to be on the blue list. And so sometimes that time difference from being added to when the technology is advancing, sometimes you need to utilize other lists to understand compliancy and to achieve what you need to do on certain projects.
All right. Well, thank you so much, Austin and Nick, for a great webinar today. Before we officially close out, I just have a couple reminders for the audience. Many of you have asked about the on-demand materials. So just a reminder, everyone will receive an email in the next 2 business days with a link to access the on-demand webinar and the slides. Also, if you could please fill out the short evaluation form that will appear on the webinar console shortly. This will help us better serve your needs in future webinars, and your feedback is greatly appreciated. Thank you again to Austin and Nick for a great webinar today, and thank you to all of our attendees for taking the time out of your busy day to join us. Again, this webinar was brought to you by Commercial UAV News and sponsored by Frontier Precision. Thank you all, and have a great rest of your day.
Thank you, guys.
Thank you. Take care.